All right. So we just did a little discovery activity on the website. And hopefully during that, we noticed that as H increases in vertex form, right? So here's H, right? And you can see this number is getting bigger. As H increases, the vertex of the parabola moves to the right. In other words, the x coordinate of the vertex gets larger. And then as it decreases, it translates or moves the graph to the left, right? Because as H gets smaller, as it decreases, right, the x coordinate of the vertex gets smaller, and the inside the equation it becomes the opposite of what you think, right? And so x gets bigger inside the equation, it's negative. As it gets smaller, it's positive, right? Just like in point slope. And then as k, which is the y coordinate of the vertex, and it's outside the equation here, right? As it gets bigger, the function moves up, and as it gets smaller, as it gets closer to negative, then it moves down. And the most basic function, remember, is this 0, 0 function. So all parabolas start out of this base function here. So let's look at a couple of different equations, and we're going to talk about how to graph them. So here we have this function, f of x equals x minus 3 squared plus 2. And so from that, we can figure out the x and y coordinates here. We know that the x coordinate is inside here, and it's the opposite of what it looks like. So that's going to be positive 3. And then the y coordinate is outside, and so it's going to be positive 2. So we can go ahead and graph that point like that, or I already went ahead and did it this way. There's that point, 3, 2. Now what we're going to do is we can start plugging in values around there, right? And so since my x coordinate is 3, probably a good place to start would be to plug in a value that's 1 greater than that. So 1 greater would be this 4 value. And so now I'm going to plug that into the equation. All right, so here I've plugged in into the equation. I've plugged in 4 into the equation because it's 1 away. It's 1 greater than the x value of the vertex. I plugged in 4. 4 minus 3 is 1. 1 squared is 1. Plus 2 is 3. And so I plugged in a 4 and I got out a 3. And that is this point right here. Now, we also know that if I plug in 1 away in the other direction, in other words, minus 1, I'm going to get the same value out. And that's going to give me this point, 2, 3. And they're mirrored. They're a mirror image of each other that's reflected across the axis of symmetry, right? If you imagine a little mirror placed in the middle, all points on one side of the parabola are going to be mirrored on the other side of the parabola. So now let's plug in a value that's 2 away. So I'm going to plug in 5 into my equation. All right. So over here, I plugged in 5. And you can see that 5 minus 3 is 2. 2 squared is 4. 4 plus 2 is 6. And that gives me the point 5, 6. And then, and so that would be plus 1. So that's that point. And then I thought it would be interesting to go ahead and plug in 1, right, which is 2 away in the negative direction. In other words, it's the x value minus 2. Okay. So I plugged in 1 minus 3. It's negative 2. Negative 2 squared is 4. Plus 2 is 6. And so that's the point 1, 6. And so that's where it gets its mirror image, because if you square something negative, it's the same thing as squaring something positive. Now, after you've done all that, you can sketch your line. Let's do another one. All right, so as I look at this equation, I've got this equation, f of x equals x plus 4 squared minus 2. As I look at this, I know that my x coordinate is right here, and it's negative 4. And my y coordinate and I know that it's the x coordinate because it's inside next to the x, right? And the y coordinate is outside next to the y, and I can say that it's -2. Okay, and so those are those coordinates. Okay, and I can go ahead and graph those, my vertex point there, and so that's that point right there, -4, -2. Now I'm going to plug in a value that's one greater than my x value, so I'm going to plug in -3. All right, so I went ahead and plugged in both values that are 1 away from -4. So I've got my vertex is at -4, so I plugged in -3, and -3 plus 4 is 1. 1 squared is 1, minus 2 is -1. So that's the point, -3, -1. So that's that point right there. Then I plugged in -5 just to show how it works. -5 plus 4 is -1. -1 squared is +1. Minus 2 is -1. And I get the point -5, -1. So that's the -1 point that are mirrored across each other. And then I can go ahead and do, so then a +2 value would be -2 here, right? And I'm going to go ahead and do all that work. All right, so I plugged in -2. -2 plus 4 is +2. Squared is 4. Minus 2 is 2. And so I get the point -2, +2. And then I can mirror that point across the x-axis, across the axis of symmetry to -6, +2. And then I can draw my function. And there we go. All right, so the next thing is, given a graph like this, how could we write an equation of that graph? So looking here, I've got this, my vertex is at the point 0, 2. So in other words, my h is 0 and my k is 2. So I could say, if I was going to write this in f of x, then I could say, well, if my h is 0, I could put a 0 here, and then my k is 2. Now I don't really need that 0, so I could say that this is the function f of x equals x squared plus 2. In other words, there's no horizontal translation. There's just a vertical translation up 2. Here's another one. So I can see that my vertex, the x-coordinate is 4 and the y-coordinate is 0. So I could rewrite that as f of x equals x minus that 4, the x-coordinate of the vertex, squared. And I could put plus 0 here, but I don't really need to. Let's see what it says. Yep, that is in fact it. Oh, except you can't really see it that well. Here we go. Once you erase everything else. And you can see that the x-coordinate is inside that function right there. Let's write one last equation based on the function. As I look at this one, I can see that x-coordinate is 4 and the y-coordinate is -2. So I could call this f of x equals x minus that x-coordinate, so x minus 4 squared minus 2. And, you know, it's always interesting that the y-coordinate looks exactly like it should, and the x-coordinate always is the opposite of what you think it's going to be. And that's just because the x is next to the x, and the y is on the opposite side of the equation, right? We've subtracted that k to get it over there, or added that k to both sides. Anyway, hopefully this helps, and now you can go and do homework 13, and hopefully that'll be easy.